Hello, and welcome to Hazard Communication Training. Today we will discuss how to work with hazardous chemicals in the workplace safely. We will discuss a variety of topics during this session. The lesson objectives are to detect hazardous chemicals, recognize physical and health hazards, different ways to protect yourself from hazardous chemicals, the requirements of the written hazard communication program, labeling requirements, and safety data sheet requirements. Let's get started. There are safe methods for detecting and observing that hazardous chemicals are present or have been released. For some operations, automatic air monitoring equipment that will detect hazardous chemicals and display their airborne concentrations has been installed. However, employees often need to rely on portable sensing equipment, testing tools such as litmus paper, or their own senses to detect the presence or release of hazardous chemicals. Employees who use chemicals should be familiar with information on a chemical's appearance, odor, and physical and chemical characteristics before they work with the chemical. Even if you aren't regularly working with hazardous chemicals, you should be alert for any strong chemical odors that you may notice in the workplace, but you should not purposely sniff to try to identify chemicals or detect a release. The same rules apply when trying to identify a chemical by touching it, or to find out if it feels oily, for example. A hazardous communication program takes steps to ensure that all chemicals in the workplace are identified. But if you encounter an unknown chemical, you should consider it to be hazardous and get more information about it before anyone uses it. There are two general types of chemical hazards: physical hazards and health hazards. A chemical can have both physical and health hazards. Chemical manufacturers and importers refer to 16 predefined physical hazard classifications, 10 health hazard classifications, and 2 environmental hazard classifications when they classify the hazards of a chemical. Each of those classes can have up to 5 subcategories. Once all of the hazards of a chemical have been classified, the warning statements, phrases, and other label elements are then specified. Classification information is also used to create a safety data sheet. A chemical is a physical hazard if it can damage the workplace environment. This means chemicals that are classified as having one or more of the following hazardous effects: explosive, flammable, oxidizing, self-reactive, self-heating, and others. A chemical is a health hazard if it can cause an illness or other health problems. This means a chemical that is classified as posing one or more of the following hazardous effects: toxicity, skin corrosion, eye damage, respiratory issues, possible cell mutation, and others. Some of these health hazards can occur rapidly following a brief exposure. This is an acute health effect. Health hazards can also cause long-term effects that usually follow prolonged or repeated long-term exposure. This is called a chronic effect. Hazards can be reduced or eliminated through the use of engineering, administrative, and work practice controls. An example of an engineering control would be to install ventilation equipment to reduce exposures. An administrative control could be substituting less hazardous chemicals or implementing a chemical handling procedure. If the hazards cannot be completely controlled or eliminated through other measures, personal protective equipment is used. The employer assesses the need for PPE by surveying work areas and identifying sources of chemical exposures. Appropriate PPE is selected based on this assessment of the hazards and an evaluation of the PPE's effectiveness at protecting from the hazards. Employees who are exposed to hazardous chemicals may be required to wear chemical-resistant goggles, face shields, gloves, chemical-resistant boots, chemical-resistant coveralls or aprons, respirators, or other items of PPE. PPE, however, does have limitations. For example, protective gloves or clothing can rip or tear, or a respirator may malfunction. Employees are not to use damaged or malfunctioning PPE. Fires, explosions, chemical burns, asphyxiations, and other catastrophes can be the result when hazardous chemicals are involved in an emergency situation. We have mentioned that unknown chemicals are to be considered hazardous. In case of a chemical spill or release, the identities of the chemicals might not be obvious. In this situation, it is especially important to treat the chemicals as hazardous. Specially trained emergency responders need to manage situations where unknown chemicals are involved in a release. You still play an important role in the response, even if your only responsibility is to evacuate to a safe place. If you witness the release, go to the safe place and report the incident. Knowing how to promptly report an emergency is very important. Equally important is to follow the proper emergency procedures. It is a good practice to always be aware of how to follow a safe evacuation route from wherever you happen to be working. First aid information for contact or overexposure to the chemical is available on its safety data sheet. Take it seriously and report the incident right away if someone is overexposed to any chemical. Prompt first aid and medical attention can prevent a serious injury or illness. For many chemicals, the first thing to do if there is direct contact with the eyes or skin is to rinse with plenty of water. That is why OSHA specifically requires emergency eye wash stations and showers to be ready for immediate use near operations involving the use of harmful corrosive materials. It is also a recognized best practice to provide emergency eye wash and shower facilities when employees work with any hazardous chemicals that would be severe irritants or be otherwise harmful to the eyes and skin, even if they are not identified as being corrosive. Another common route of exposure is to breathe chemical vapors, gases, aerosols, fumes, or dust. The typical immediate first aid response for this type of harmful overexposure is to take the victim to an area with fresh, clean air and call for emergency medical assistance. If hazardous chemicals are swallowed, it is not always the best practice to induce vomiting. It may also not be a good practice to have the victim drink plenty of water. In this situation, call the Poison Control Center or emergency medical responders and have information from the SDS readily available. OSHA's Hazard Communication Standard includes requirements for chemical classification, safety data sheets, labeling, written hazard communication program, employee information and training, and finally provisions for trade secrets. Next, we will begin to discuss the labeling of containers. The purpose of labels is to warn about potential dangers. Labels are not intended to be either the only or the most complete source of information regarding the hazards or identity of hazardous chemicals in the workplace. They serve as an immediate warning and as a reminder of the more detailed information provided in other formats, such as SDSs. All container labels must be in English, but information may also be presented in other language for non-English speaking employees. Labels are required on containers of hazardous chemicals. Container means any bag, barrel, bottle, box, can, compressed gas cylinder, drum, reaction vessel, storage tank, or the like that contains a hazardous chemical. However, pipes or piping systems in engines, fuel tanks, or other operating systems in a vehicle are not considered to be containers. Chemical manufacturers or importers classify chemicals hazards, and they use that information to prepare the labels that you see on shipped containers of hazardous chemicals. Labels for shipped containers must have these 6 required elements. 1. The product identifier. This is the name or number used to identify the chemical. It will also be used to identify the chemical on the safety data sheet and the list of hazardous chemicals in the employer's written hazard communication program. 2. Signal word. This helps you know how severe the hazard is. The word danger is used for the most severe hazards, and warning is used for the less severe hazards. Next is the hazard statement. This is a brief statement for a hazard class and category to describe the nature of the hazard. A pictogram, which is a symbol used to show you the chemical's hazard class. There are 8 pictograms used to meet the Hazard Communication Standards labeling requirements, and 1 additional pictogram is used to show environmental hazards. Precautionary statements recommend the steps you should take to safely use, handle, and store the chemical. Finally, the name, address, and telephone number of the chemical manufacturer, importer, or other responsible party. The responsible party is someone who can provide more information on the chemical and what to do in case of the emergency. Any hazardous chemical products that come in through your doors or leaves your workplace will have this type of label. This image shows a sample label up close so you can better see all of the required elements: product identifier, signal word, hazard statements, pictograms, precautionary statements, and the manufacturer or importer's contact information. There is no guesswork on the standardized elements. That information is provided within the Hazard Communication Standards required classification system, and once the manufacturer knows the chemical hazard by class and category, those label elements fall into place. The label's pictograms are possibly the most visible aspect of the labeling system. There are 9 pictograms used. Here we see 3 of the 9 and the hazards that they represent. Flame over the circle is used for oxidizers. The flame is used for flammables, self-reactives, self-heating chemicals, and other flammable hazards. The exploding bomb is used for explosive and self-reactives. These 3 pictograms represent chemicals that have toxic, corrosive, or compressed gas hazards. These last pictograms are probably the ones you will see most often. Health hazards is used for carcinogenics, respiratory sensitizers, reproductive toxicity, target organ toxicity. Exclamation mark is used for irritant, skin sensitizer, acute toxicity, narcotic effects, and respiratory tract irritations. You'll note that both the health hazard and the exclamation point are used for health hazards. The level of the health dictates which pictogram is used. The health hazard pictogram indicates more severe hazards than the exclamation point. You might also see labels using an environmental pictogram to show aquatic toxicity hazards. OSHA's Hazard Communication Standard doesn't require the use of the environmental pictogram. Employees can rely on the labels that were on the containers when they arrived in the workplace. OSHA does not require containers to be relabeled unless the label falls off or it becomes unreadable. When hazardous chemicals are transferred into another container, the new container must be properly labeled. There is a very limited exception to this. If the person who transfers the chemical will be the only person using the new container during only his shift, then the container does not need to be labeled. But it is always a good practice to make sure the contents of any container are identified. Signs, placards, batch tickets, or printed operating procedures can be used in place of labels on individual stationary containers, such as tanks. Some employers opt to use a different labeling system to label in-house workplace containers of hazardous chemicals. OSHA does not require any particular system to be used when relabeling in-house workplace containers, but the labels must include the product identifier and words, pictures, symbols, or a combination of these that provide at least the general information on the hazards of the chemical in the container. Two of the most common workplace labeling systems in use are the National Fire Protection Association and the Hazardous Materials Identification System. Both systems identify the name of the hazardous chemical. NFPA identifies 4 hazard categories: health, listed in the blue diamond; flammability, listed in the red diamond; reactivity, listed in the yellow diamond; and special hazards, listed in the white. The degree of severity for each hazard is rated with 4 representing your highest hazard. HMIS identifies the following hazard categories: health listed as blue, flammability also listed as red, physical hazards will be listed as orange. A white bar at the bottom of the label identifies PPE to use when handling the chemical. The degree of severity for each category is rated from 0 to 4. In addition, an asterisk by a number may indicate the chemical has chronic health effects, or more information is available on the safety data sheet. Labels provide an immediate hazard warning, but you can find detailed information about a chemical's hazards on its safety data sheet. A safety data sheet is a fact sheet for a hazardous chemical. There must be an SDS available for each hazardous chemical in the workplace. Chemical suppliers provide the safety data sheets, but the employer is responsible for making sure the sheets being used are kept up to date. They must be in English, but the employer may have copies in other languages as well. Safety data sheets must be immediately available to you while you are in a work area. Copies must be kept where you can use them during your work shift. When employees must travel between workplaces during the day, safety data sheets may be kept at a central location. Let your supervisor know right away if you can't find an SDS or you think one is missing. There are many reasons why employees would want to check the SDS. For example, you may want to verify label information, determine if you're using the recommended PPE, learn about the symptoms of any health effects related to exposure to the chemical, and review recommended first aid and emergency procedures. Safety data sheets must contain the following sections in the order listed. Section 1. Identification. This includes the product identifier, manufacturer or distributor's name, address, and phone number, an emergency phone number, recommended uses, and restrictions on uses. Section 2, hazard identification, includes the hazard classification and the required label elements. Section 3, composition information on ingredients, includes the chemical name, common name and synonyms, chemical abstract service number, percentages of ingredients and mixtures, and trade secret claims. Section 4, first aid measures, includes necessary measures for each route of exposure, important acute or delayed symptoms and effects, and any immediate or special treatment requirements. Section 5, firefighting measures, lists suitable extinguishing techniques and equipment, hazardous combustion products, equipment, and special precautions for firefighters. Section 6 discusses accidental release measures and lists personal precautions, protective equipment, emergency procedures, and proper methods and materials for containment and cleanup. Section 7 is regarding handling and storage. It lists precautions for safe handling and storage, including any incompatibilities. Section 8 discusses exposure controls and personal protection. It will list OSHA's permissible exposure limits, threshold limit values, and other recommended exposure limits. It will discuss appropriate engineering controls as well as personal protective equipment. Section 9 discusses the physical and chemical properties of the hazardous chemical. Section 10 discusses stability and reactivity of the hazardous chemical. It will discuss incompatible materials, conditions to avoid, and the possibility of hazardous reactions. Section 11 discusses toxicological information, specifically routes of exposure, immediate as well as chronic health effects. Section 12 is ecological information. Section 13, disposal considerations, includes a description of safe handling and disposal. Section 14 regards transportation information. Section 15 is regulatory information and will include any product-specific safety, health, and environmental regulations. The final section, Section 16, is titled Other Information. It includes the date of preparation or last revision of the safety data sheet. This now concludes the hazardous communication training. If you have any questions, please contact your direct supervisor. Thank you.